welcome to today's presentation around the Automatiko project. But this time I would like to show you a bit of an example inspired by a blog post from Piotr Minkowski around the Kafka streams with Quarkus. So it's a really interesting use case, as you can see throughout the blog post, that we handle kind of a stock market use case where we send orders for buying and selling. Then we have the Apache Kafka in between that performs the work. So I don't want to introduce you to the use case itself, but please have a look at the blog post. You can find it here and read through it, get yourself familiar with the use case, because this use case actually inspired me to look at it from a different angle. Instead of using Kafka streams, which I'm not experienced with, so I decided to take a look at if we can do that with workflows instead. So the order service becomes the same as it was, but the stock service is replaced with the workflow based service instead. So without further ado, let's quickly look at what it means. So we have checked out the project from Piotr. So we have our order service that stays exactly the same, meaning that it will send out every half a second orders for buying and selling, randomly selecting the product. Then we have the stock service, the original one that is based on the Kafka streams. And then we have new one that is the workflow service, stock service, that is actually replaced with the workflow information. As you can see, it's pretty much the same logic as it is in the Kafka stream. So we have the message entry point for buy orders, then we have the sell orders. We correlate those based on the product ID. So everything that is for particular product ID will be merged into the same workflow instance. Then we have the matching orders, which is the actual business logic, meaning that we find based on the amount and price, we find the right orders that we can match and properly create transactions. And as soon as we have the transaction created, we calculate total. So this is the analytical part that is described in the second part of the blog post from Piotr, and that allows us to immediately calculate the total amount of information or total amount of transactions performed, and so on and so forth. And lastly, we publish the message, so it goes out to the order service that simply logs that. And lastly, as the use case describes, the orders can be valid only for 10 seconds. That means that every 10 seconds the workflow instance will scan for outdated orders, and those are outdated orders, regardless if it's buy or sell, will be removed. And with the options for doing the Automatiko part, this workflow will expose an endpoint, and individual instances will be immediately available through that endpoint for inspection. And those lists of information, they are not shown as the output of the service, but the transaction total information is exposed. So whenever you ask the endpoint for a particular instance, you will get the information about the statistics or the analytics there. Looking at the actual source code, so we have obviously the workflow definition file, but then from the source code perspective, we have the information about the model. So it's pretty much the same thing as it is in the original one. The difference here is that we don't need to have the transaction with product, because we already have the workflow that is excuse me, that is already taking care of that. The stock service is pretty much the same, so it's the business logic that we have. Here we have the processing of the orders that is used for matching. We calculate the statistics. As you can see, the transaction total, remove the outdated, and the same execute method and match orders. So those are pretty much the same things that are in the original source code. All right, so let's get this running. So here we first start the order service, and then we start the original excuse me, stock service. So the order service, as described in the blog, it will create a Kafka broker based on the red panda, and it starts submitting the orders, right? As soon as this one starts, it uses the Kafka streams to connect and join into it, and you can see it processing the transaction and creating transactions and so on and so forth. can see here that we have sending orders, we have the new transactions, and so on and so forth. So that is the original blog post. So if we shut down this one and then instead start the one based on the workflows, it should pretty much the same, take the same place of the SOC service, consume data from the stream. It's constantly, as you can see, it's producing constantly every half a second information, and you can see already we have the timer schedules here. So those are the clean up, and after 10 seconds it will start cleaning those, but you can see that the workflow is as well producing new transactions. So it's pretty much the same behavior. And what I would like to show you, so this is the, if we go to 8080, oh sorry, we should have got already here, like this. So we can see this is our service, this is the endpoint directly showing that information, and here we have all the instances. As you can see, the key represents the actual product ID that was generated, and I can see it collects those information. This is the unique identifier, and here is the key. So we can actually use the keys as well to access our instances. So let's, like for instance this, and as you can see, we get immediately the total information. So that is the statistic, our product number with ID1. Can you use that ID5? Or if you like, we can get all. So with that, I would like to conclude for today, and hopefully you enjoy it. It is an excellent blog post from excuse me, from Piotr. So I encourage you to take a look at that, and if you are interested in the source code, it's original in the Piotr repository. I did a fork of it to include the workflow service, so you can find here, and you have the information how to get started with that as well. So with that, I would like to once again thank you very much for listening, and have fun. To the next time.